The next three charts are similar charts, except that instead of line charts, these are area charts. It's the same thing. Instead of drawing a line, you draw an area. So it's somewhat different than line charts. Okay, so you have to be very careful interpreting this. Usually, the line chart is the best. The area charts, they kind of look nice, so it's good to impress some people, I guess. But from a technical point of view, just plain line charts are the best. Okay, so here let's select sales and order date. Okay, and product category. Take product category also, and if you click the area chart, then you see that this one is office supplies, and then that part is this technology, and then office supplies, and then furniture. So it sits one on top of the other. It's different from what we see here. Okay, the line chart is different. Okay, so here the line charts are plotted, the actual values are plotted in the lines, whereas here the difference is plotted. Okay, so I'm sorry, take that back, not difference, it sits on top of it. Okay, so this part is just office supplies, and that part is just furniture. So one sits on top of the other. Okay, you see the difference there? And of course, once again, you can make it continuous quarter, or you can use discrete time. Okay, the next one is discrete. So this is continuous and that is discrete. And of course, if you select discrete, you can change to continuous later on if you want, easily. So the same thing, if you select sales, product category, and order date, and select that one, will give you a discrete area chart. Okay, so that blue pill shows that it is a discrete time pill. And then finally we have that one, which is a dual combination plot. And dual combination plot again looks similar to there are two axes. So we have, say, average time to ship. Okay, time to ship is something that we have to calculate. Okay, so here is a kind of a side topic. Okay. We want to demonstrate that, and we're going to plot two different measures. One is sales, and then superimpose sales on top of that, time to ship. Okay, how do you compute time to ship? Time to ship is the difference in the dates between ship date, which is right here, and order date right there. So what is the difference between those two? And we can express that as how many days are in between, or how many months are in between, or how many years are in between. Okay, and we can do that using, there is a function in Tableau, okay, called date diff. So create a calculated field, okay, and we'll call that time to ship. Okay, and we have date diff right there. Okay. Now the first thing that you have to specify is how do you want to measure the difference in the two dates, and there are several keywords. You can use day or quarter or things like that. Okay. Then start date and end date. What is start date? Start date is order date. And end date is ship date. Okay, now you see it says the calculation is valid. So most of the calculated fields that you can find are quite easy to set up, and there's a bunch of functions that are available. So click OK. So now we have time to ship as one of the measures available to us.
What did you put for start of week?
Start of week, okay, sorry, I didn't say anything about that because that's optional. Start of week, sometimes you can have Monday as start of week, or Tuesday or Sunday as start of week, and that would make a difference in some functions, but here it doesn't matter to us, so we'll just leave it. We won't do anything with it. Okay, so let's take here your order date, okay, time to ship and sales. That, then we have for every year we have the sales and then the time to ship. Now time to ship, how would you want to plot that? Okay. If you use sum of sales, so here the aggregation is sum of sales. So sum of sales would be that you have order 1 has $1,000 of order, order 2 is $1,500. So you keep adding, then you'll get the total sales, which is what we want. How much did we sell in a given year? You keep adding the sales amounts from one order to the next. That's good. Now time to ship, so first order takes say 3 days to ship. Second order, next order takes 2 days to ship. Now if you keep adding the time to ship values, what do you get? You get the total of all the shipping days, and that means what? Nothing, right? What you actually would want is the average shipping time. So for each order, you want that sum to be divided by the number of orders, so you will have the average time to ship. The total time to ship has no meaning for us. Total sales has meaning, so that's the total amount of sales that we have had, but total time to ship has no meaning, but average will have meaning. So we need to really change that, okay, change that to average. Okay. Then you see that average is used and not sum. And since you will never want sum, you only want average for time to ship, you can set that here. You go to time to ship, okay, and so you have default properties, okay, and under aggregation, if you change it to average, so from that point onwards, whenever you use that particular measure, the aggregation will be average and not sum. Okay. So let's go ahead and do that. Change that to average. So if we use this measure elsewhere, average would be the aggregation that will be used.